This is part 2 of the solubility and parts of a solution lesson. And this part we're going to talk about concentration and saturation, which describe a solution. Last video we talked about what solubility is and the different parts of a solution. Then we have solute, which is dissolved in the liquid, and then the solvent is the liquid itself. Usually the solvent is water. However, there are other solvents because of course there are other liquids that you can put things in. So solute and solvent, and then how dissolving works. This video we're going to start out by defining concentration, and concentration is the measured amount of solute in a solution. So when we're talking about concentration, something that has a lot of solute in its ratio compared to the solvent, we would say that is concentrated. And if something has less solute, or maybe it has more solvent, it's like watered down, we would call that diluted. So two words that go along with concentration, we've got concentrated, which is lots of solute, and we have diluted, which is, you know, a little of the solute in that ratio of solute to solvent. We measure concentration in a ratio of solute to solvent called molarity. And we will talk more about molarity next week. That will be our main focus. But that measures moles per liter. It's kind of like density, but for specifically for a solution, the amount per volume, amount of solute or stuff dissolved per amount of liquid solvent. If you have a large molarity, it will be concentrated, and if you have a smaller molarity, it is diluted. The other term is saturation, and saturation has to do with how much the solution can actually hold. It's kind of its carrying capacity, if you will, of solute. And it depends on a couple of factors, but the main one is the amount of liquid. So if you have a certain amount of liquid, it can only hold up to a certain amount of a certain solute. But you can also manipulate the saturation, which we will talk more about on Wednesday, by heating it, stirring it. You know, even adding more water will allow you to add more solute. So the saturation level has to do with how much the actual solution can hold. If it is a saturated solution, then that means that our solution contains the maximum amount of solute. For its amount of solvent. If more particles could be dissolved in the solution, then it's unsaturated. So for example, if I was saying that I have a saturated solution of salt, I'm going to draw a little beaker here. We know that the solutions, let's say this is an electrolyte, so we're going to fully dissociate those particles. And I'm just going to pick an amount here that is going to be my saturation level. I'm just going to say having 2 of each is saturated. If I were to add more salt to my saturated solution, what will happen is I already have saturation. It's my maximum amount. So instead of being dissolved, any extra salt that I add will just clump up at the bottom. It will not dissociate anymore. So I will just have NaCl collecting on the bottom. That is a saturated solution. You could have saturated showing your clumps at the bottom, or it could be saturated solution all dissolved in it at the perfect maximum. But generally a saturated solution will have excess at the bottom because we won't know the exact perfect amount in the real world, or even if we do, it's hard to measure exactly the amount that will be dissolved. So usually a saturated solution will have a little bit at the bottom, and then an unsaturated solution still has room to dissolve more, and it won't have any excess at the bottom. So you can use that in number 4 through 7, that concept of saturation. On number 4, you're going to just pick, kind of like I did, an arbitrary amount of lithium and chlorine that's going to be representing saturated, and then you're going to add more, literally just like I did for sodium chloride. And then 6 and 7, you're going to change your solution to an NO3 with it being unsaturated, and then add more to your unsaturated, that should say solution, it got cut off, showing what that would look like from adding to a saturated solution. This concentration exploration has to do with lemonade and looking at the amount of solute to describe its concentration and defining some terms. So you should be able to kind of walk through this. Number 5, you're defining these terms on your own based on what you see in this exploration, and then we will kind of chat through this on the Zoom or on Friday, depending on where we have the amount of time. And then the last page is page 7 for saturation. You will count the number of particles in each beaker. So literally count, I've got 1, 2, 3, 4, 5 particles dissolved. How many solid? 0. There's none at the bottom. Okay. Then here, same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and still 0 because there's none dissolved at the bottom. You can do C, D, and E, so that's count the number. Then color code your beakers, unsaturated and saturated. So you pick a color, or I'm just going to do a pattern since I don't have color. I'm going to do stripes and stars. Or no, we're going to need stars in a minute, so I'll do shading. Striped or shaded. If it's striped, it's unsaturated. So looking at my stuff, if I can add more, then it's unsaturated. That one would be unsaturated. This would be a saturated solution. Can't add any more. Okay, so you do the rest. Circle the most diluted, the one that has the least amount of solute per solvent. You circle that, and then star the most concentrated. And there can be more than one, noting that S, plural. There can be more than one, meaning they have the same concentration. Remember that concentration has to do with the amount of solute dissolved in the solution. If it's excess at the bottom, it's not going to affect that concentration one bit. And then you have a couple of questions. What would happen to the concentration of beaker E if you evaporate some water, and explain? And how could you make beaker D and E look like beaker C? So I want you to answer those questions, and we will discuss these on the Zoom and or on Friday, depending on where we have the time to do it.